So we've seen how we can translate and reflect shapes in the coordinate planes, right? We found those specific like algebraic rules that we can use. Let's see if there's any patterns that we can use with rotation. So step one, we got to plot this figure on the coordinate plane. And I'm going to go ahead and plot that with you just so in case you need any help with that. Otherwise, feel free to pause the video and plot it yourself. But the first point A is at 2, 1. What that means is 2 to the right and 1 up. So here's point A. Point B is at 6, 1. So 6 to the right and 1 up. There's point B. Let me move that over here. Okay, point C is at 4, 5. So 4 to the right, 5 up. And there is our triangle. So we've got it there. Now we're going to perform some rotations. And again, feel free to use your tracing paper, right? I like to trace the figure, put it here. And for it to work on mine, I'm going to need to add a point here. Let's see, about here. Okay. And I'm going to go ahead and group these together so it's ready to rotate. So what we're going to do first is rotate it 90 degrees counterclockwise. So remember, clock, which way the clock goes, we're going to go the other way. All right, so here it is, 90 degrees counterclockwise. Boom, there it is. Okay, so I'm going to go ahead and write the points out. That's A prime, B prime, and C prime, right? A is now at -1, comma, 2. B is now at -1, comma, 6. And C is at, sorry, I forgot the one there. C is at, let's see, 5 and up. There, okay, so -5, comma, 4. All right, now let's perform the 180 degree rotation and see what happens. So I'm going to rotate it again here, 180 degrees. There it is, about there. I'm going to write this one in just red because it's a different figure, right? This would be prime, double prime, second rotation. A double prime is right here, right? At point, right there. That's at -2, comma, -1. B is at -6, comma, -1. And C is at -4, comma, -5. And then one more rotation here, right? We're going to go for the 90 degrees clockwise, which we already said is the same as 270 counterclockwise. So here, or we can take our original figure and rotate it 90 degrees this way. And there it is with those last set of points there. So the question A, and I should have probably answered these as we went, it said turn it 90 degrees. Do you notice anything with the new coordinates? So if we were to look 90 degrees counterclockwise, how these coordinates are related, right? Oops, let me make that a little bit bigger highlighter. Right, we're looking right with this, for example, right? It was 2, 1, now it's -1, 2. So original was x, y, right? And now it is, for the 90 degrees counterclockwise, it is now, x is now the y coordinate, and negative y, or the opposite of y, is now the x coordinate. And we can see that's true with all of those other figures there, okay? Right? It should be 6, 1 is now, 6 is now the y, -1 for the x, and then same here with the last set of coordinates. All right, let's look about after the 180 degree rotation there. This is question D on this page. And I'm just going to sketch it right here. So looking at those coordinates, it was 2, 1, now it's -2, -1. So with the 180 degree rotation, we can actually see that it's -x and -y. It doesn't mean the points are always negative. It just means this negative symbol means the opposite of, right? So the opposite of 6 and 1 is -6 and -1. The opposite of 4 and 5 is -4 and -5. If it had a point at, let's say it had a point at -3, 2, it's now going to be at 3, comma, -2, because that opposite is what that negative symbol means, is the opposite of it. And the last set is 90 degrees clockwise or 270 degrees counterclockwise. I think 270 degrees counterclockwise is a little redundant. That's why I'm going to say 90 degrees clockwise more often than not. So let's see how those points are moved. So here was our point A at 2, 1, and here it is at 1, -2. So with this 90 degree clockwise, we can see that the y is now x, the coordinate, and the x is now the opposite. And so you can see there's a very similar subtle difference between the clockwises. The x and y switch, but the y changes when we go counterclockwise, and the x changes when we go clockwise. Right, the x coordinate switches. And I think the main reason for that is when we're looking at the shape, let me rotate it back to its original spot here. If we were to go counterclockwise, we are moving the shape into this coordinate. This is where we see those x coordinates switch to negative. That's why we're going to see this x coordinate switch signs. Whereas if we're going clockwise, we're going to see the x's are still positive, but now it's the y's that change, which is why we see the y coordinate is now its opposite. And that was kind of the main idea with this. These are the algebraic rules, and you can actually see those on the next page as well, that I have these written in your notes, where you can see the different kinds of rotations, the different directions, clockwise, counterclockwise. If you ever forget, you can always look at the clock in the classroom, right? But there's those rules listed right here for us. And then I did put equals here, right, for both clockwise and counterclockwise.